Okay, I'm going to do a little video here, talk about sketch bends, using sketch bends rather, to create offset jogs, and also using just regular flanges to create offset jogs in Alibre sheet metal. What I have here is a model of a UL NEMA Type 1 enclosure, and as you can see, it has some offset jogs around the front perimeter, and those are easily created in the base part by incorporating that into the sketch for the contour flange. However, when you get to these mounting tabs, those need to have some special treatment, and that's what I'm going to be demonstrating here on this video. So on this part here, before I get into actually demoing the creation of the offset jog, I'm going to point out that in my equation editor I have added some parameters that I'm going to use to control my offset height, OH, my offset angle at 45, and the flange length, which is the offset height divided by the sine of the offset angle. And I'll be demonstrating how those parameters get utilized in both sketch bend and flanges. So to begin with, if I'm going to put an offset jog or tab on the body of this or face of this panel, then say I've got a component that I need to mount on an elevation other than the surface of this panel. Get 0.5 rather than 5, and we'll just locate this here in at ½ inch off the end and ½ inch off the side here. If I could hit my decimal point, it'd be a little bit easier or quicker. And we'll make this 1.5 long. Now, before we exit this sketch, I'm going to have that bend along this line, but I also need to reference this line so I can locate my second bend. And in order to do that easily, what I'm going to do is insert an axis from the sketch by going on the sketch ribbon and clicking on this icon. I can also get there by going to the sketch menu and insert axis. Either case or either way, you get this dialog, and all you got to do is select the line and click apply and then close. Then we'll go over and switch over to the sheet metal tab or ribbon and hit sketch bend, and it's going to naturally pick a line to bend on, and in this case it selected that short line, and it's got an angle here of 90 degrees, and we're going to change that by clicking on FX. We're going to select our offset angle. That changes our offset angle. Now next we need to position our bend relative to the bend line and axis, and we want that to be outside of that line. So if you notice, if you look at this on end, this surface and this surface are going to intersect at the bend line by picking this outside option. And then OK that. Now on this face, which is going to be this same surface basically as this surface, we're going to start another sketch and add another line. And what I like to do is make the end points of the line coincident to the edge of that raised tab, and then we're going to dimension this from this line to the axis, and hitting FX again, we'll go into our parameters, and we're going to select FL parameter for the flange length and OK that, and then go into sheet metal ribbon again and hit sketch bend and reverse the flange, reverse the tab, and then again our offset we'll just key in OA for offset angle. And now we're going to check the position of this bend so that we want to make that so that this surface and this surface are going to intersect this bend line. So we're going to select the inside in this option and then hit OK. And now if we measure this from this face to that face, we have our 1/4 inch. So there you have an easy way that's repeatable for mounting, for installing offset jogs on tabs in your sheet metal. Now to create an offset jog using flanges, so we want to create a flange along this edge at a 1/4 inch offset. We'll hit flange and we'll select this edge. And we'll select outside on that. And then as far as flange length and flange angle, for flange angle, we'll come in here and we'll click on get our parameter of OA, and flange length. We'll come in here and we'll select our flange length parameter. And now here, you want to make sure that we get the inside length set there, and then click apply. And now we're going to pick this edge and we'll see, got our angle at matched at 45 here at OA, and I'll leave our length there at 1 inch, and click apply and close. Now let's measure this from there to there, and we're at 2719. So we've got to check our alignment here. Actually, select, let me delete this. Try this one more time. Reverse the flange and apply, and let's see what that one does. Still too high. Let's change this to inside and check it one more time. And there we have our 1/4 inch. So, two different methods of getting an offset jog on a piece of sheet metal and driving them with this set of parameters in the equation editor. Now, one thing I'd like to point out here too is that if I already had these parameters entered in my sheet metal part file in the equation editor, and I should point out that in my I have a series of parts already set up as part templates, and all of these different gauges have the equations already preset in the part file, so that all I need to do is open up my part template, do a save as to the name of what I'm going to create, and I've got my equations already preset that I don't have to be re-entering anything in the equation editor. So the other thing that I want to point out or bring to your attention, whatever, is if I go in here to change my material, if I hit select from library and go down to my mild steel, I can add whatever material I have here. I can add to my favorites list. So I select add to favorites, click save, and then cancel. Now if I come up here and right click, now I can change my material to my 1010 material right off of the favorites list. So anyway, there's how to create some jogged offsets and a couple of tips on creating templates and saving materials. So hope this helps.